Okay, let's dive right into this. Welcome to today's explainer, where we're going to completely shift the way you look at those small, everyday movements. Now, if you've ever watched a learner really struggle to hold a pencil, maybe trace a shape, or even just place a sticker, your first thought was probably all about their hands, right? Well, today, we are going to fundamentally change that mental model. We're moving away from seeing these struggles as just a hand problem, and instead, we're going to discover how they're actually a design solution. It really all comes down to a question that gets right to the absolute heart of learning. Why do some activities build skill, while others literally only create struggle? We've all seen it, that visible, heartbreaking frustration of a learner repeatedly failing at a task, erasing until the paper literally tears, or just throwing their hands up and giving out entirely. It's tough to watch. But what if I told you that difficulty doesn't just reside inside the child? What if the barrier isn't their physical capability at all, but actually the way the task itself is built? To really wrap our heads around this, I want you to picture something for a second. Think about trying to write on a table that just keeps wobbling. Now, even if your hand is perfectly capable of beautiful, flawless handwriting, the task suddenly becomes incredibly hard. And why? Simply because the support system beneath it is completely unreliable. This vivid analogy perfectly captures exactly what learners experience. These small, precise actions, they don't just happen in a vacuum. They depend entirely on a much larger, incredibly stable foundation to work properly.
So let's look at part one, the hidden motor system, beyond the hand.
We really need to dismantle this common misconception that fine motor skill is just this one single isolated ability. It's not. Think of fine motor development sort of like the careful arrangement of objects in a traditional Beijing courtyard. In those spaces, nothing is there by accident, right? The spacing, the sequence, the pathways, they all actively shape how you navigate that space. Well, fine motor skills operate exactly the same way. A really neat pinch or a careful cut with scissors requires postural stability, visual clarity, force control, feedback, and task design all communicating together instantly. Fine motor skill isn't a movement, it is a complex coordination problem.
And when we actually map this whole system out, it's wild because we see exactly what goes wrong when just one single link breaks down. For example, if postural stability is weak, the hand has to work way harder than it should just to compensate for a wobbly body. If visual clarity is missing, the learner burns all their mental energy just searching the page instead of actually taking action. A weak link basically forces the learner to waste an immense amount of effort just trying to keep control of their body, which leaves absolutely nothing left in the tank for the actual task. Now, a massive part of that control is something called calibration. And calibration is simply the ability to find the exact right amount of force. Think of it like turning the volume knob on a speaker. The goal isn't just to make a sound. The goal is to make the sound the right level for the room you're in. Fine motor ability isn't just about hitting a specific target on a piece of paper. It's about matching the precise, appropriate pressure the second you get there. You can see this super clearly when we contrast the extremes. What happens with too much pressure? The learner tears the paper, they completely smash their crayon tip, or they overshoot a line. But what about too little pressure? Well, their mark practically disappears, their grip fails, or the object just slips right out of their fingers. A lot of times, we watch a learner move their hand accurately to the exact right spot, but the final result looks, quote-unquote, careless. But in reality, they aren't careless at all. They simply have a force matching problem. Which brings us to part two, how vision shapes action, guiding the hand. So how exactly does the nervous system know how much force to use or even where to go in the first place? Let's use another really powerful analogy. Imagine trying to thread a needle, but you're doing it in really dim light. The problem isn't that your hands suddenly forgot how to work, right? The problem is simply that the target is obscured. So the crucial takeaway here is this. When a task is visually uncertain, like when the lines are super faint or the page is just totally cluttered, it massively increases the cognitive load. The brain can't confidently guide the motion, and that instantly destabilizes the learner's physical movement. So whenever we're looking at any learning material, we really have to pause and ask a much deeper question. Does this activity help the learner actually notice what matters? Because an activity is always doing two jobs at once. Sure, yes, it's asking for a movement, but its hidden and honestly way more important job is teaching the nervous system how to actually improve that movement. If the task doesn't highlight what matters, the learning just stalls out entirely. And the specific visual features of a task completely change the learner's physical experience. Think about it. Clear boundaries literally act like a GPS, telling the hand exactly where to go. Strong contrast lets the eyes instantly separate the target from the background noise. Reduced clutter preserves the learner's precious attention bandwidth.
These are absolutely not just pretty aesthetic choices. These specific visual communication designs actively reduce uncertainty. They clear the static so the learner actually has the breathing room to develop true physical control.
Okay, let's move on to part 3, designing for true skill, the sweet spot.
Now that we know how this whole system ticks, it's time to shift into some practical design principles to find that perfect balance between totally mindless success and overwhelming tear-inducing failure. Real skill building is all about finding just enough challenge. Imagine trying to balance a heavy book on one finger. If the book is too light, you don't learn anything because it doesn't challenge your balance. But if it's way too heavy, the entire problem just becomes about collapse rather than control. We are constantly looking for that Goldilocks zone. A brilliantly designed activity doesn't remove the challenge entirely. It carefully separates the challenge into digestible little parts that the learner can actually handle.
Let's look at how this builds into an actual usable framework for layering control. First, a learner has to see the target, then plan the move, hold their body steady, control their force, monitor what happened, and finally adjust. If you ask a learner to do all 6 of these things at maximum intensity all at the exact same time, they are going to crash. Strong activity design acts just like a staircase. You don't jump straight to the top floor. You stage the challenge step by step so the learner can build one layer of control firmly on top of another without burning out.
But what happens when we don't stage it properly? Well, you start seeing some pretty massive red flags. The learner can't even figure out what the goal is. Every single attempt looks rushed or completely random. Their hand posture is constantly shifting, just because they're struggling to read a cluttered page. When you see these signs, you know for sure the activity is producing struggle, not skill. It's asking for way too much all at once. And honestly, the worst part is that it's merely hardening their mistakes rather than teaching them a better way to move.
Which brings us to what I consider the absolute core mantra of this entire explainer. Difficulty is not only inside the child, it is also inside the design. This is just a massive paradigm shift, because once we finally stop instinctively blaming a learner's physical capability, we completely unlock the power to actually fix the environment they're trying to operate in.
And that brings us to our final step, part 4, becoming a skill builder, diagnose and design.
It's time to take everything we've unpacked today and completely shift your mindset. You are moving from being just a passive observer of performance to someone who actively designs the conditions for learning, because that is exactly what you're doing now. You are no longer only noticing performance, you are diagnosing conditions for learning. You literally have the structural model now to intelligently look at a worksheet, a craft, or a tracing task and immediately distinguish true motor difficulty from just plain bad design difficulty. You have the tools to actively shape the learning system.
To wrap this all up, I want to leave you with one final, incredibly powerful question. The next time you look at a fine motor task, whether you designed it yourself, you bought it online, or you're just handing it to a learner, don't just ask whether it got completed. I want you to ask, is it teaching control? Because I promise you, when you start asking that question, you change absolutely everything for the learner. Thanks so much for joining me on this explainer, and I'll catch you on the next one.